All right, so today we're going to talk about graphing and solving two variable inequalities. So we talked about one variable inequalities and graphing them on a number line, but now we have an XY coordinate grid and we're going to look at how that can work with inequality graphing. But we're actually going to start off with just the equation of a line. We've been working on this and working on just graphing in slope-intercept form. And when we have an equation like this one, y equals 2x minus 9, remember that on the line, there really are an infinite number of solutions or ordered pairs on this line. All right, so what we mean by that is that there are an infinite amount of points that are on the line. And every one of those points, if we put the x value of the point in for x and the y value in for the point in for y, it will make a true statement. So each xy pair on the line represents a solution to the equation. So let's go ahead and graph this line. Remember, on the line, we're going to start off with the y-intercept value. So -9 is the y-intercept, where the line is going to cross the y-axis. Remember, we've got y-axis and x-axis. So it's going to cross the y-axis at -9. And then we have the slope of 2. So from our y-intercept value, we're going to rise 2 and then run 1 to the right. So going up 2 and over 1. Remember, slope is 2 over 1. So rise 2, run 1. Up 2, right 1. Up 2, right 1. And every single one of these is a point on the line and is also a solution to the equation. So we can keep doing this until we run out of space, and that goes on forever, and then we can actually connect these up, make a nice straight line, and there is the graph of the line, y equals 2x minus 9. So let's take a point that is on that line and show why it is a solution. So for example, let's take the point right here. Let's take that point. So this is the point 5, 1 right here. X value of 5, Y value of 1. So let's take the point 5, comma 1. 5, 1 is a solution to y equals 2x minus 9 because it is on the line. But why else can we show that it is a solution? What's another way of showing evidence that that is a solution? Well, let's just think about that for a sec. Let's go ahead and take the y value for that point and put it in for y. And let's take the x value for that point and put it in for x. All right, and see what that gives us. So we'll take the y value for that point, which is 1. So we'll put that in for y. And we'll take the x value for that point and put it in for x. So instead of y equals 2x minus 9, we put 1 in for y and 5 in for x. And this is really a question. Does 1 equal 2 times 5 minus 9? Let's do the math here. 2 times 5 is 10. Is 1 equal to 10 minus 9? Question mark. 10 minus 9 is 1. Yes, 1 does equal 1. So that proves that that point is a solution because it makes the equation true. Okay, so if we point the point 5, 1 makes the equation true. We've talked about this before. We're showing more evidence of that. This is a review. But now let's go ahead and think about what that would mean for an inequality. All right, so inequality, notice we've changed the equal sign into a less than or equal sign. So we graphed a whole line of points in number 1. It's really the same equation here, same inequality type of situation. Are these points solutions to this inequality as well? So if we change the equal sign to a less than or equal sign, is that still true? All right, and then if we think about that, since it's less than or equal to, then yes, if we checked our answer, we would get, so if we did the same thing as we just did up here, we would get a final answer. Instead of 1 equals 1, we'd have 1 is less than or equal to 1. The only thing we changed between here and here is just the sign. We've changed it from an equal sign to a less than or equal to sign. So if we look at changing this from an equal sign to a less than or equal to sign, is that still true? Is 1 less than or equal to 1? Yes. 1 is equal to 1. So yes, 1 is less than or equal to 1. So that is also true. So 5(1) is a solution to the equation back up here, but it's also a solution to this inequality down here. Okay? So in fact, that means any points on the line are solutions. But also now, since it's less than or equal to, we can say and any points below the line are solutions. Okay, so the points on the line are solutions because we showed that back up in number 1 up here. But the thing is with inequalities is that we have lots of solutions. We noticed that before when we were doing the one variable inequalities on the number line, that's why we used an arrow to show all the solutions, because there were an infinite amount of solutions, not just one solution. Same thing with two variable inequalities. There's going to be an infinite amount of solutions. So if we just regraph the line that we had from number 1, again, y-intercept is -1, slope was 2. So let's go ahead and graph that. So y-intercept is -9 and the rise 2, run 1, rise 2, run 1. So we're just going to graph those same set of points, just like we did with the same equation in number 1. Okay, make a nice line. Okay, so all these points on the line are solutions. All right, they are going to make the equation true. They're also going to make this inequality true because they are equal to the line. But since we now have a less than or equal to symbol, that means all of the points that are below the line are also solutions. Okay, so if we picked a point that was below the line, just pick any point that is below the line. I don't know. Let's pick the point 5. I'm going to pick something positive up here. So I think this point right here is 8,2. All right, this is the point 8,2. Note it is below the line. It's in that little pink shaded region there. Let's just prove that that is a solution. So the point 8,2, let's show. So let's put, remember this is an x value and a y value. So let's put 2 in for y. And let's put 8 in for x. So is that, oops, sorry there. Is that true? Is 2 less than or equal to 2 times 8 minus 9? Let's see, 2 is less than or equal to, that'd be 16. 2 times 8 is 16. 16 minus 9. Is 2 less than or equal to 16 minus 9? Well, 16 minus 9 is 7. Is 2 less than or equal to 7? Yes, 2 is less than 7. So we now know this is true. In fact, any points below the line are going to make that inequality true. So they are also going to be solutions. So there's an infinite amount of solutions to this two variable inequality as well. And there'll be any xy ordered pairs, we call them, or points, any of those points that are on the line or below the line.